what I want to talk about now is, let me do this in a different color pen, reading and a classic exam question would be something like this. What types of bonds can this molecule make assuming that a suitable partner exists, and draw that the suitable partner and the bond. All right. So that's a sort of classic exam question. And so let me give you an example structure. This is from the this is sucrononic acid. The exact name isn't that important. It's from warm-up number 3. That was the one we talked about the different sweet molecules. So I just want to draw, I'm going to draw it up, and then what I want to do is focus in on some really important parts of it. So let's make I want to draw this picture. Some parts of the details are important, some are less. Let's see, this is O to N. I'm sorry. Draw that carefully. There's an H over here to a carbon, double bonded to a nitrogen, hydrogen. One of these zigzaggy things. Have people draw this because it's worth the practice to draw these things, to get used to the way we draw them. O, H. All right. What I'm going to do is focus in on 3 parts of this molecule. Bless you. So part A, and if you like, you could just draw the little tiny bits if you want. If it's trying your patience to draw the whole thing out, you could just draw the little parts. The B, and likewise, let me draw just this part here. C. All right. So there are 3 parts of this molecule, A, B, and C. And what you need to be able to do, for a variety of reasons, is to diagnose that molecule. What kind of bonds can those parts make? Right? And we're going to take them piece by piece. And the bonds that we care about are the non-covalent ones. They are ionic, hydrogen, van der Waals, and phobic interaction, the big 4. So ionic, hydrogen, van der Waals, phobic. So what I'm going to do is have you all think about it. We'll go A first, then B, then C. That should be enough. So that when I want people to talk about it with their neighbor, I want to know, for each of the 4 bond types, can part A, can it make an ionic bond? Can it make a hydrogen bond? Can it make a van der Waals bond? Can it make a hydrophobic interaction? We're going to do the same thing with B and the same thing with C. How do you know that? And then if it can make, a hydrogen bond, what would a hydrogen bond partner look like, and how would you bond it there? So let's start with A. Think about it. Talk to your neighbor. All the big 4, ionic, hydrogen, van der Waals, and phobic interaction. What are the 4? Which of those 4 can it make? Why? And then let's think about how you'd make a bond to that. And so think about it. Talk to your neighbors, and we'll call names, et cetera, et cetera. All right, so get a consensus on the big four: ionic, hydrogen, van der Waals, and phobic. And again, it's, as we saw earlier, having the wrong answer is oftentimes more useful than having the right answer. So I'm happy to hear what people have to say, right or wrong. So get a consensus, and I'll call names. All right. So Jürgen, are you here, sir? Or Jürgen? Yes, sir. Tell me. So pick a bond. What are the four? Yay or nay? No, I'm sorry, for part A. So which bonds can it make? So can it make a hydrogen bond? Can it make or ionic bond? So you say yes to a hydrogen bond. All right, cool. Let's take that piece by piece. All right. So how do you know it can make a hydrogen bond? It's got a special hydrogen, right? And also, it has a lone pair on oxygen. So basically, it has an OH bond. That's an H bond donor. And it also has a lone pair on an oxygen, which is an H bond acceptor. Therefore, it can make H bonds. Right? Cool. All right. Let's see. Does that make this part phobic or philic? Philic, because it could make hydrogen bonds with water. So is a hydrophobic interaction possible with this part of the molecule? No, because hydrophobic interaction is phobic with phobic. If this is philic, it can't do a hydrophobic interaction. Therefore, it's philic. Therefore, no phobic interaction is possible. Okay? What about ionic bonds? Yay or nay? No, and there's a lot of quiet people out there. How would you know? Sabrina, pardon? So what do you need to make an ionic bond? A charge, a plus or a minus charge. Is there a plus or minus charge in that part? No. So can you make an ionic bond with that part? No. Maybe I could imagine changing it so it was charged, but that doesn't matter. There's no charge up there now, so there's no possibility of an ionic bond. So this one here, we would say there's no plus or minus charge, therefore no ionic bond is possible. All right? So we've taken care of hydrogen bonds, we've taken care of phobic interactions, we've taken care of ionic bonds. What's left? Poor little van der Waals. And what's the story on van der Waals? Always yes. Like I said, if you fall asleep and you wake up and I say, can do van der Waals, the answer is yes, it can do van der Waals, yes, because everything can. Okay? Questions? Yeah. How would you draw a van der Waals bond? You'd have to draw. It's like it would be a squiggly line. It's basically anything other than a solid line. So let me show you. So let me draw these guys. So to draw a hydrogen bond, there are many possible. We could do the classic one to water. All right, so that would be a hydrogen bond. Van der Waals, I don't know. We'd have your OH to, I don't know, anything like a CH, whatever, and there'd be this sort of a squiggly line between them. All right, some sort of symbol like that. Something. Let me draw a better dotted. Let me draw a nice dotted line. That way, it's clearly not a solid line because it's hard to see it on the screen. All right. All right. So what I'd like people to do is parts B and C. Likewise, that sort of analysis. Talk to your neighbor, etc., etc. So part B was that long squiggly line, right? And C, well, I'll draw it in when we come to it. But it was here, I'll scoot it so that people can see it. Here's B, and so B and C. So talk to your neighbor, B and C, and we'll diagnose them the same way. So we'll do B first, and then C. So let me get a consensus. Let's scoot down to B. Let's see. All right. So Connor, Pearson, Connor, where are you, sir? Connor, are you out there? Going once? Going twice? Okay, Connor, that counts. It costs you a point for being absent when your clicker's here. David Barkas. David, are you here? David. So, pick a type, yay or nay. Start anywhere you like. For which one? So you want to say it's hydrophilic, okay? Because why? You want to pass this time? I'm getting this quiet. Or you want to? You got your neighbors to bail you out? Okay, all right. That's fair enough. That's actually that's good to know. I thank you for trying. All right. So let's take this piece by piece. Hydrogen bonds. Yes or no? No. Why? No special hydrogens. Are there hydrogens here? Tons of them, but they're not special. All right, so no special H's, therefore no H bonds. Ionic bonds, yes or no? I got a yes, I got a no. What do we need to see for an ionic bond? Is there any charge there? No. So no charges. No charges, no plus or minus, therefore no ionic bond. Therefore, this thing is which? Phobic or philic? Phobic. This is phobic. All right. If that's phobic, therefore, can you make the hydrophobic interaction? Yep. It's possible. And you might draw that something like this. To some other hydrophobic thing like that. All right? And also van der Waals, yes or no? I won't draw it, poor little van der Waals. All right. So, questions about that guy? All right. It doesn't have to be just that you said no, but there are other people. C. All right. Let's do part C. And then there's a little bit more to do after that. So C has got this thing. All right. Let's just do this as a shout out. So, hydrogen bonds. Yes. To what? To which atom or atoms? Can you make a hydrogen bond to the nitrogen? No. There are no lone pairs here. All right. Can you make a hydrogen bond to the hydrogen? Yes. It is a special hydrogen. So yes, the answer is there's an H bond donor, NH, and you could make a hydrogen bond to water if you like. All right. There's no H bond acceptor, but that's okay. You still can make a hydrogen bond. So H bonds are possible. All right. What about ionic? Yes. Yes. Plus charge. So you could do your N plus with its things connected to it, whatever, and it could make an ionic bond to some sort of oxygen minus attached to whatever, right? So ionic, possible. All right. Is this thing philic or phobic? Philic or phobic? Philic. Because the answer to these things is yes. Therefore, no phobic interaction. All right. And lastly, van der Waals, yes. All right. Questions about that one? Yeah. I would put it the other way around. It is philic because it can make ionic and hydrogen bonds. And because it's philic, you can't do the phobic interaction. Does that make sense? Right. Right. It's because you can interact with water, it's charged and it's going to make hydrogen bonds. That means it's philic. And if it's philic, it's not going to do the phobic interaction. Yeah. Yeah. Mm-hmm. Did I write what? Oh, you know what? I'm really sorry. That should say phobic. That's meant to say interaction. It's phobic. Let me put it. Let me just put. I beg your pardon. That's my atrocious handwriting. I meant to say not. It meant to say phobic int, looking like not, but phobic is possible. Right? Phobic interact. Let me like. You know what? Let me write this interaction. That's what I get for abbreviating. Phobic interaction is possible. All right, cool. Other questions? Yeah. Why is it ionic? Why does ionic make it philic? Because that's charged things can interact with water as well as hydrogen bond things. So charges and hydrogen bonds, so things water likes. There's actually one more thing I want to do. If you look at the last page of today's information packed handout, if you want to I'm going to have to steal like 2 minutes after the end of class, the normal end of class, because I want to make sure to do this carefully. So I know it's almost time to go, but this is important because this is also another exam question to put these things in order. So how do you rank structures from most phobic to most philic?